Assalamualaikum and good afternoon to Dr. Azliza. Today I want to present about my proposed project, which is the AI-based web application Real-Time Malaysian Sign Language Translation and Learning. My SV is Dr. Rohaila binti Maskat. First of all, background of the study. It includes communication importance. Communication is very essential for social equity, but the deaf and hard of hearing DHH community often face significant barriers when interacting with hearing individuals. In global and local contexts, over 1.5 billion people live with hearing loss. In Malaysia, Bahasa Isyarat Malaysia (BIM) or Malaysian Sign Language (MSL) is the primary language, but the use of it and understanding is limited to the general knowledge, which leads to the social and educational exclusions. Next is the sign language nature. It is a visual spatial language using manual, hand gestures, and non-manual includes facial expressions with body postures. Next is the problem statement. This gap is evidenced by four key findings, which is communication gap. There is a lack of knowledge regarding BIM among the community and a shortage of practical real-time translation tools for casual use. Talking about technical limitations, most existing systems focus on static gestures, which is alphabets and numbers, whereas BIM is primarily dynamic movement over time. Next is hardware barriers. Recent high-accuracy systems often require expensive, specialized hardware, like sensor gloves, which are impractical for daily use. Last but not least, lack of learning aids. Existing tools focus on translations, but neglect interactive education, making it hard for non-signants to learn sign language. Next is research questions. Firstly, what deep learning model is suitable for recognizing MSL while considering spatial and temporal characteristics? Secondly, how can a deep learning model be designed to effectively recognize dynamic gestures in real time? And thirdly, how can a web-based application prototype be developed with an integrated learning module? Next is the research objective. Firstly is to identify a deep learning model for MSL recognitions that considers spatial and temporal characteristics. Secondly, to design a deep learning model for recognition and learning of MSL. Thirdly, to develop a web-based application prototype for real-time translation with an interactive learning module. And then the research scope. Number one, the current research focuses specifically on Malaysian Sign Language and does not consider other languages. Number two, video recordings made by a standard web camera used as input data and no special equipment is required. Number three, sign language recognition task is limited to isolated dynamic sign language, where each gesture is performed individually rather than continuous sign language sentences. Number four, a deep learning model is used to recognize sign language gestures by considering both spatial and temporal features with an emphasis on performing in real time. Number five, the system is developed in terms of a web-based application prototype and thus will be accessible through the standard web browser. Number six, the learning module is designed to encourage learning and practice in sign language, providing feedback based on recognized gestures, but it is not designed to replace formal sign language education or professional instructions. And lastly, the target audience would include the deaf and hard of hearing community, non-signers who want to learn the Malaysian Sign Language, and students or educators interested in additional learning resources in sign language. And then the research significance. It includes quality education because it provides an interactive learning module for non-signers which align with SDG 4. Moreover, it promotes independence for the DHH community which align with SDG 10, reduce inequalities, and then it enabling effective communication between DHH community and institution spheres including public service and legal settings which align with SDG 16. In addition, technological perspective, it demonstrates the visibility of transformer-based models for real-time and vision-based applications. And lastly, the national, it supports the Malaysia Madani vision of inclusivity and the MICE-T framework. The following table summarizes the key research trends identified in the sources. Firstly is the approaches. Vision-based webcam is preferred over sensor-based which is glove for practicality. And then the feature extraction. MediaPub is the current standard for extracting 21 hand landmarks and facial cues in real time. And then model evolutions, transitioning from CNN, spatial only, and LSTM GRU recurrent or sequential, to transformer, which is global temporal dependencies. And lastly, the gap. Most studies focus on non-Malaysian language, and there is a research gap in applying transformer to PIM. This table presents the research methodology adopted in this project. The study begins with data collection of BIM gesture videos, followed by data preprocessing and landmark extraction using MediaPipe, and then the extracted features are used to train a sequence-based sign language recognition model. Finally, the system performance is evaluated and implemented as a web-based prototype. Continue to the system architecture. This diagram illustrates the overall system architecture of the proposed sign language recognition system. Video input is captured through a camera and processed using MediaPipe to extract gesture landmarks. These landmarks are formed into gesture sequences and classified by the recognition model. The predicted output is then displayed through the web-based application to support sign language learning. And then the expected outcome of this project is a trained sign language recognition model and a functional real-time web-based prototype. The system will be able to recognize dynamic BIM gestures and support interactive learning for users. To conclude this, the project proposes a vision-based approach for recognizing dynamic Malaysian Sign Language gestures. The system aims to improve communication accessibility and support sign language learning through a real-time prototype. This research contributes socially, technically, and academically to the field of sign language recognition.